In this video, we're going to look at an introduction to a new topic called complex numbers. Okay. Now, first of all, I want us to look at this equation. If we were asked to solve this equation, x squared plus 16 is equal to 0. You might think, all right, well, it's a quadratic, does it factorise? No, maybe try the quadratic formula, that might be an idea. Or you might even think, because it's just x squared, there's only one x term, could we try and rearrange it? And let's see what happens. So we'd end up with x squared would equal minus 16. And at this point, you're probably going to say, hang on a minute, something's going on here. Like, there's no solution to this, is there? Because if you square a number, you don't get a negative. Okay? So up until this point in maths, you just say, oh, there's no solutions, and move on. But with complex numbers, essentially all we need to realise is that this topic is going to give us a tool to solve these equations. So in maths, we love finding ways to represent solutions, don't we, to different equations. And instead of just saying, well, there's an equation that we can't solve, we're going to look at a technique which allows us to solve it. Now, the solution is not a real number. There's no real number that if you square a real number, you don't get minus 16. But that's where complex numbers comes in. It's going to allow us to represent the solutions to this equation. Okay. Now, the first thing that we can do is we introduce an imaginary number which has got this property. So if we square root minus 1, we denote that by the letter I. And you probably want to highlight that in your notes. That's like one of the main points on this whole topic. Okay, so if I square root minus 1, I can represent the solution by the letter I. Okay, so let's look back at our equation. X squared equals minus 16. And what we'd then do is we would square root both sides. We would remember the plus and the minus. Okay, so if x squared equals minus 16, x is equal plus or minus the square root of minus 16. Now, before this topic, we would just say, well, there's no solutions, you can't square root minus 16. But what we can do, if we remember how surds work, let's actually, before we do this, I'm going to give you a little recap on surds. So imagine if we had the square root of 18. Remember, a really important property with surds is if that number inside is a product, we can write it as the square root of 9 times 2. And the property with surds is that then would allow us to write it as 2 surds multiplied together. So we know the square root of 18. If we can write that as a product inside, we can also write it as a product outside. So 2 surds multiplied would be the same as this. Why would we want to do that? Okay, so if we've got a number with a factor, that's a square number, isn't it? So we could write that as the square root of 9, which is 3. And then a better way of writing the square root of 18 would be 3 root 2. So taking that knowledge back here, we can write this as the square root of 16 times by the square root of minus 1, because minus 16 is just 16 times by minus 1. Maybe include a little step in between. You could write minus 16 as 16 times by minus 1. And now that we've done that, what's the square root of 16? 4. What's the square root of minus 1? I. So now we've just solved an equation that we couldn't solve before. Okay, did quite a lot there in one example, so let's do a couple of simpler versions and then we can practice some of those. So if I, for example, wanted to work out the square root of minus 81, we can write that as the square root of 81 times by the square root of minus 1. And then what's the square root of 81? 9. What's the square root of minus 1? I. So this said, we could write as 9i. Let's try another one. What's the square root of minus 2? What's the square root of 2 times by the square root of minus 1? Now, you're not always going to be able to simplify these. Like the square root of 81 is 9. The square root of 2 is just the square root of 2. The square root of minus 1 is I. Now notice that be careful how you write that. That I is not inside this square root. Make sure you clearly have that outside. Okay? So the square root of minus 2 is root 2i. Okay? Let's try a couple more from exercise 1. Okay, so possibly pause the video and have a go at these. If you're not sure, obviously just watch and I'll go through them. Okay, so for this first one, square root of minus 64, you can write that as the square root of 64 times the square root of minus 1. Square root of 64 is 8. Square root of minus 1 is I. Next one, square root of 225 is square root of 225 times the square root of minus 1. Use your calculator, obviously, if you're not sure. Square root of 225 is 15. Square root of minus 1 is I. Okay, for this next one, we've got two surds which are separate. Don't try and multiply these together. We've got to keep these are clearly two separate things. So the square root of minus 100. I've done a few of these now. I'm going to skip this step. Like, but after you've done a few, you should be able to skip it. We know it's a negative, so it's going to have an I in it, and the square root of 100 is 10. So that's 10i. Square root of minus 4. Square root of 4 is 2. Square root of minus 1 is I. So 10i plus 2i. 12i. Okay. Now we've got a multiple of 5. So we can think that's just 5 multiplied by the square root of 121, and then the square root of minus 1. Square root of 121 is 11, so what we're doing now is 5 times 11. Square root of minus 1 is I. So we'd get 55. I. Last one looks a little bit awkward because you've got some algebra thrown in, but don't panic. Let's just use the same rules. So the square root, don't forget, minus p squared is the same as p squared times by minus 1, isn't it? So we could write it as the square root of p squared times by the square root of minus 1. Now the square root of p squared is p, the square root of minus 1 is I. Okay.